Welcome to SS Mathematics classes for juniors. Today in our lecture we will discuss on integration by parts. What is it? First see. Here we integrate the product of two functions. As we differentiated product of two functions, UV rule was there, ddx of uv equals to u dv dx plus v du dx. In the same way, here the rule is all about to integrate product of two functions. Here two functions u. Here u is called first function, and v is called second function, and both functions are functions of x. That is why we integrate this product with respect to x. The rule is, first see what is the rule. The rule is, if u is the first function, if you take u as the first function, then the rule is u integration v dx minus integration whole du dx, that is derivative of u with respect to x, into integration v dx whole dx. This is the rule. Okay. And one thing is very important to remember. You have to be cautious about taking the first function and second function. If you mistake to do the choice of taking first function and second function, you may not complete the integral. So, taking first function, that is choosing first function and second function, is very much important. See, for this integral example, we are taking an example. Suppose x sine x dx. Okay, here you must take x as first function and sine x as second function. But instead of that, if you take sine x as a first function and x as second function, you might be in trouble. See, first we take x as first function and sine x as second function, and apply this rule. X integration sine x dx minus integration ddx of x integration sine x whole dx, and then integration of sine x is minus cos x, know very well, minus cos x minus, this is 1, this is minus cos x, plus cos x and dx equals to minus x cos x. Okay, and what is the integration of cos x? It is sine x, and then c, constant of integration. This is the end of the integral. But instead of taking x as first function, if you take sine x as first function, what happens? See, alternately, if you take sine x as first function, this is the integral. If you take sine x as u and x as v, okay, sine x according to this rule, sine x integration x dx minus integration ddx of sine x integration x dx whole dx. Next, this is x square by 2, x square by 2 sine x minus, this is cos x, is x square by 2. We take half out of the integral because it is a constant, cos x into x square dx. So, instead of reducing the difficulty level in the integral, here what we got is difficult type of integral because initially the integral was x sin x, but after choosing sin x as first function, here we get another integral which involves x square cos x. So it is more difficult to solve than the original integral x sin x dx. So you have to continue the process. But if again you take cos x, that is a trigonometric function, as first function and x square as second function, you will be in deep trouble. So choosing first function and second function is very much important, what I told you before. So next I discuss some standard integrals of integration of bipairs. See, let us discuss on some standard integrals in integration of bipairs. Number 1, integration e to the power ax sin x dx. It is nothing but an integral. Here e to the power x, it is an exponential function, sin x is a trigonometric function, and its result is e to the power ax by a square plus b square. A is b sin bx is a sin bx minus b cos bx. At the end, constant of integration c is there. You can write this result in alternate way, e to the power ax by root over of a square plus b square sin bx minus tan inverse of b by a. It is a very easy derivative from this line. That is, you can bring this line from this line very easily. Number 2, e to the power ax cos bx. Here a, b are nothing but real constants. Its formula is e to the power ax by a square plus b square, a cos bx plus b sin bx plus c. And alternately you can write e to the power ax, some derivations are required, e to the power ax by square plus root over of b square plus b square cos bx minus tan inverse of b by a plus the constant of integration. These are the very important integrals for future mathematics. In higher mathematics, we often use these two standard integrals. Other three formulas are there. Integration root over of x square plus x square dx equals to x root over of x square plus x square by 2 plus a square by 2 log mod x plus root over of x square plus a square plus c. This is number 3. Number 4, integration root over of x square minus a square dx equal to x root over of x square minus a square by 2 minus a square by 2 log mod x plus root over of x square minus a square plus c. Okay. And at the end, number 5, number 5 is integration root over of a square minus x square. Now what is the difference between 3 and 4? Similarly, here if under square root sign plus is there in the middle, plus will come. If minus is there in the middle, minus will come. Okay, and if plus is there, this will be plus, and if minus is there, this will be minus. But in both the cases, under logarithm, x plus will come. This is the similarity, and this similarity is here. It is plus, it is minus. If it is plus here, it will be plus. If it is minus here, it will be minus. And this is completely different. Here in the question, in formula number 4, standard integral number 4, here the integral was root over of x square minus a square. Here the integral is root over of a square minus x square. So let's see what is the result. X, the first term is same, root over of a square minus x square by 2 plus last a square by 2 sine inverse. So this is the last or second term. So these are the all 5 formulas we generally see in the chapter of integration by parts. So these are the 5 formulas. Let's see some problem. And you can easily derive these standard integrals. Okay. So in this class, I will not discuss about these formulas elaborately. Instead, we take some problems from the very well-known book S&M, Mathematics class 12. Now, what is the benefit of this chapter? See, we already discussed about integration by method of substitution, etc., etc. But if you see, you will find there is no method, there is no integral of this type, integration sine inverse x dx, or there is no integral like this integration log x dx, or integration x log x dx, or integration x cosec x dx. So by doing this chapter, by doing this method, integration by parts, we not only be benefited to solve integrals of product of two functions, but we also be benefited to solve this type of integrals, integration sine inverse x or integration log x dx, which we could not solve in earlier in a method of substitution or etc. So this is the advantage area of doing integration by parts. Okay, let's take some problems from our book. So first, I solve this integral sine inverse x dx. How can I solve? You may say there is only one function which is sine inverse x. It's an inverse circular function. So no u v, that is there is a single function So how can we apply integration by parts? That is, for integration by parts rule, you have to have two functions. One is u and the other is v. But you can argue that, sir, here only one function is there. How can you apply this rule? See, how can we apply this rule? You may consider 1 into sine inverse x. So you may consider 1. Now, which one you take as first function? See, it is very important. Which one you take? If you, what was the rule? Integration u integration v dx minus integration du dx integration v dx whole dx. So you have to integrate v. So which function you take as second function, that must be integrable. So you have to take that function as second function which is easily integrable. Okay. So we know that we cannot integrate sine inverse x easily. So it is natural choice to take sine inverse x as first function. So take this as u and this as v. Here v is a constant function 1. So according to the rule, there sine inverse x integration dx, because 1 we do not write 1 here, minus integration d dx of sine inverse x integration dx whole dx. Okay, so integration dx you know very well, it is x sine inverse x, we write x generally in the first place, minus integration, what is the derivative of sine inverse x? One thing you must remember, in the integration by parts chapter, you have to remember all the derivative formulas very well, because you can see here derivative is there, du dx, you have to differentiate the first function you take. So what was the formula? Integrate d dx of sine inverse x, 1 by root over of 1 minus x square is integration dx means x dx. So x sine inverse x, don't put constant of integration until the total integration is over. Sine inverse x minus integration x dx by root over of 1 minus x square dx. So for this integral, for the second integral, that is, we are writing this integral, the second part separately. For this integral, you use general method of substitution, that is what you did earlier, root over of 1 minus x square, take this as u, a new variable u. So this implies 1 minus x square equals to u square, and this implies minus x dx equals to u du. Very simple thing. So this is x dx means minus u du by root over of 1 minus x square is u. U will be cancelled out. Minus du, that means minus u. That is minus u means root over of 1 minus x square. So just put the result of this integral here. So this will be x sine inverse x minus this minus plus root over of 1 minus x square plus. So this is the complete result. So with the help of integration by parts, we solve this type of integral what we could not solve with the use of general method of substitutions earlier. So this is the advantage point of integration by parts. Let's see another problem, which is integration log x. integration log x. See, here is also, you can see here only one function, log x. But how can you handle, how can you apply integration by parts? Because to apply integration by parts, you need to have two functions. Okay, well, you consider 1 into log x. Okay, so take log x as first function, because you have to differentiate, you have to integrate that function which you take as second function, because we cannot integrate log x. So we must take log x as first function. So log x integration 1 dx, we do not write 1, minus integration ddx of log x integration dx whole dx. Okay. Hope you noted all well. So I am working all this out. So what is the second, third line? See, it's very easy. So integration dx is x. Write x before log x, because if you write x after this x, it will be confusing. Minus integration 1 upon x into x dx, x log x minus x will cancel out, integration dx means x log x minus x plus c. So this is the integral. So with the help of integration by parts technique, we also solved this integral log x, which we could not solve earlier with the usual method of substitutions. Okay, so these are the advantage points of doing integration by parts. In our next lecture, I will take some problems, important problems from the book SND book, that is mathematics book on class 2. Okay, thank you, bye bye.